very much, Professor Ertl. So we have time for some questions. Dr. Muradian.
All these pictures, beautiful pictures, which you show, are connected with rotation, yes? And what is angular momentum of this rotation? These spirals, yes.
Yeah. There was a question whether we have only left-handed or right-handed spirals, but we have exactly the same number of spirals in both directions. So it's just a matter of the initial conditions. And it's a very slow movement, very, very, very slow. But there is no preferential orientation of one of the spirals, right and left. Yeah. It's no momentum. These are reaction taking place. Pardon?
I said that in one spiral, nevertheless, there is momentum.
There's continuous reaction. There's not a motion of the whole spiral, but the propagating spiral is a reflection of the ongoing reaction. There's continuous formation of CO2, which is going over into the gas phase. There's no mechanical momentum available.
It's quite amazing that Turing was trying to apply mathematics to biology, and he said it will all be explained by physics and chemistry. And now here you have explaining chemistry on something that started in biology by somebody that didn't know any biology.
In 52, he was one of the most famous mathematicians of his time. It took over 20 years until experimental verification of these Turing patterns was obtained. But it's no question now. They exist.
Yeah, please.
In your system with the O atoms dissociating, how important is then reassociation and redesorption of O2 in that system? Does all the O react away?
Yeah. Once a molecule is dissociated, the bonding to the surface is so strong they never recombine. Okay. It would cost much more energy than to react with the carbon monoxide. And
would you expect similar behavior on more complex, less well-defined surfaces as well? If ozone diffuses, for example, on this wood surface here, would it behave similarly?
It depends on the kind of system you have. Yeah? So if the temperature is high enough, over 1500 Kelvin or so, then the oxygen atoms would also recombine and desorb again. Yeah? Mm-hmm. But at the low temperatures for the catalysts, it doesn't play any role.
And also environmentally, it would be...
Yeah, of course. Yeah,
okay.
Yeah. Mm-hmm.